Okay, grade 12s. On this lesson, I want us to continue with this question paper. Remember, on the previous lesson, we worked on question 1 of this question paper, which was analytical geometry, and we also did question 2. Right, I'm gonna put in the description, the link on the description. Sorry, I'm going to put the link on the description so that you can go and look at how we answered those other questions. So we stopped at 3.2. We did 3.2 on that lesson. Now on this one, I need to start on 3.3 going down. Let me work on that. Okay, so looking at 3.3, they say that if tan is equal to 4 over 3, where a is an element of 90 and 360. Use a sketch to determine the following. So I'm going to work on that 3.3 on this paper here. Okay, so first thing first, what are you given? That's what you need to ask yourself. What are you given and what they want you to do to solve. But I'm just going to first focus on that tan is equal to 4 over 3. So this is the first thing that I'm going to write. So we are given that, okay, let me do this. Okay, so you are given that the tan, which is 4 over 3, the tan A, it's equals to 4 over 3. And when I look at this, and they say that A, it's an element of 90 and all the way to 360. Right, so let me draw the diagram and see where is the quadrant that we need to work on. Which quadrant? So if this is 0 degrees, this is 90, I'll have that as 180 to 70 degrees. Okay, so 90 go in that side. I'm gonna put a tick in that quadrant, a tick in this quadrant, a tick in that quadrant. This is for that diagram, okay, for the interval. So it will be quadrant 2, quadrant 3, quadrant 4, but not in quadrant 1. Then look at this. The tan of theta, what can you say about the tan? The tan theta, the tan A is greater than 0, meaning it is positive. We need to take the quadrants where tan is positive, this quadrant and that quadrant. So the quadrant that has 2 ticks is where you need to draw your diagram. Okay, so my diagram will look like this. This will be my diagram then, and this will be my points here. But now I need to form something like a right angle triangle in that diagram, and this will be my angle A. Right, so this is my angle A. So now, if you look at this, according to SOHCAHTOA, tan is opposite all over adjacent. So the tan of theta, it's equals to opposite over adjacent, which is y over x. So this tells me that this is y over x. We have y, we have x, we need to find r. That's how easy the question is. You need to find r, and when you find r, look at this. My x is 4. Okay. My x is 4, but this is not making sense, guys. Let me go back to the question. Maybe I'm missing something. 4 over 3. But this is a quadrant 3. Let's think about this. Think about it. So the y values are negative in quadrant 3. So this is minus 4. And the x values are also negative. So this is minus 3. Now it makes sense because it's the same as saying the tan of A. It's like saying the tan A is minus 4 over minus 3. So the negative cancels. So I think they are trying to play with your mind here. Please don't fall for that trap. Now, please make sure that you open your eyes, and then when you substitute this, it's minus 4, not 4. So the negative cancels, but they don't put the negatives there just to see if you know that in quadrant 3, the y and the x values are negative. Okay, so now we need to use the theorem of Pythagoras, okay, to find r. So r squared is equal to x squared plus y squared. Now let's just substitute. So r squared is equal to x, which is minus 3 squared, plus y, which is minus 4 squared. Therefore, r squared is 25 because that's 9 plus 16, right? That's 25. You square both sides. This is the radius. It's always positive. So r is 5. That's your r. So r is 5. I'm just going to write it there. Let's go back and see what is the question saying. If this, use the diagram to determine the following. The sign A. Now we can find sign A. Okay. What will be the sign A? So if I'm looking for sign of A, sign its opposite all over hypotenuse. My opposite is the y value, which is minus 4, over hypotenuse, which is 5. That's the sign of A. It's minus 4 over 5. Let's answer the next one. The next question, 3.3.2, they want the cos A plus 30. So we are adding two angles. What comes in your mind? The cos A plus 30 degrees. I'm adding two angles. What comes in your mind? Should we double? Let's duplicate this step now. If you look at this, we are adding two angles. What comes in my mind is compound angle. So look at this. It's the compound angle for cos because it's a cos of plus, né? So the formula will be this one. We are adding two angles, so we can expand that and write it as the cos alpha times the cos beta minus the sine alpha times the sine beta. So that's what I'm going to apply there. I'm going to change this guy. I'm going to write this as the compound angle, which is the cos of A multiplied by that cos of 30 degrees. And then I'm going to add, since it's positive, the sign changes to negative. You don't have to stress. Just go to your formula sheet, copy down that formula, né? And then this will be minus the sine A and the sine 30. Right. So now this tells you that we need to find the cos A. Remember, cos is adjacent. The cos A, it will be adjacent over hypotenuse. So adjacent is minus 3, hypotenuse is 5. So this will be minus 3 over 5. So where there's cos A, I substitute minus 3 over 5. So this will be minus 3, everything divided by 5, times the cos 30. You just have to use your calculator on that, né? So when you say cos 30 on your calculator, this gives us root 3 over 2. We minus the sine A, it's what we calculated on the previous question. It's minus 4 over 5. Minus 4 over 5, and then the sine 30, that's half. Right, so now when I work this thing out, I'm just going to multiply the top part first. What do I get? It's minus 3 times the root 3, which is minus 3, root 3 over 5 times 2, that's 10. Then minus 4 times 1, that's minus 4. When you do that, when you add the 2, when you multiply the 2, what do you get? So it's like saying minus into, okay, minus 4 times 1, that's minus 4. And then over 10. So basically this will be positive because the negative will cancel, which gives us 4 over 10. Right, so now the denominators are the same. I think we can write this in this form and say, what will this be equals to? So if we write this in the form, it will be, okay, we can write this as 4, then we subtract that 3, root 3 over 10. Because if I have A over B plus C over B, since the denominators are the same, I can write this as one fraction. Then I add the numerators. Okay, and I think that's it for that question. Let's move to the next one. 3.4. So on 3.4, given the cos 12 is equal to P, with the aid of the diagram, determine the following without using a calculator in terms of P. Okay, without using a calculator in terms of P, and we are given the cos 12 is equal to P. So this one is different. The difference between this one, you were given a number there, but this time is just a variable. So let me show you how to use the aid of the diagram. If whatever that you are given, it's given to you as a variable. First thing first, I need you to draw the diagram. And this is how you draw the diagram. Okay, so you are given the cos 12 to be equals to P. So we are given the cos 12. This is the cos 12 to be equals to P. Okay, let me go and look at that question. Okay, the cos 12 is equal to P. So I'm going to let that P to be over 1. So this will be P over 1, right? So if it's P over 1, I know that cos is adjacent over hypotenuse. So I have X, I have R, and then where is 12 degrees? That's in quadrant 1. So my diagram will be in quadrant 1 because angle 12 degrees is in quadrant 1. So my diagram will be in quadrant 1. This is my diagram. And then this will be my angle, which is 12 degrees. This will be 90. Okay, so now what's next? Now what I'm going to do from this step, I just want to use the theorem of Pythagoras. R squared is equals to x squared plus y squared because I need the missing number. So my R is 1. So this will be 1 squared. It's equals to x, that's P. So this will be P squared plus y squared, which is what we are looking for. So 1 minus P squared, it's y squared because the P goes to the other side. What do you get when you square root? Plus or minus the root of 1 minus P squared. So that's why. Now we need to decide it's y positive or negative. How do we do that? Look at this. The y values, remember these are the y-axis. This is your x. So the y values are positive. Therefore, y will be positive the root of 1 minus P squared. And that's it for that one. So now you can start answering the questions because once you have all the values y, x, and y and r, that's when you can start answering. They wanted the sine of 78 degrees. So let me write this down. Sine 78 degrees, okay? And we need to use this diagram. So if this is sine 78 degrees, I'm going to check if I can't reduce that 78 degrees to what? Can we reduce that 78 to at least that 12 degrees? Let's check if this is possible now. So I'm going to use my calculator to check if this is possible. Let me check. I'm gonna say 90 minus 78 and see what I get when I do the 2. So it's gonna be 90. Let's minus that 78. Look at the answer, 12. So this tells you that we can write this equation and say this is the sine of 90 degrees minus 12. Because we know that 90 minus 12 is 78. Therefore, where is 90 minus? Because if I have a Cartesian plane like this, and this is 90 degrees, so 90 minus goes in that direction. You understand? Because I'm approaching 0 when I subtract from 90. So it's in quadrant 1. How is sine in quadrant 1? Sine is positive. So this changes into what? Positive the cos of that 12 degrees, which is what it was given. They said the cos 12 is P, and that's your answer. That's how you collect the mark. Then you move to the next one. Let's look at what we have on the next one. So the next one is the sine 6. How are we going to work with this one? I think it has to do with double angles, right? If I think about this, how can I create 12 from that 6? Because if I'm given the sine, what is this? Let me go back and check. Sine 6. Okay, so if I have the sine of 6 degrees, oh boy, how can I create the sine 6 without making a mess? let's think about this now. So I think what I'm going to do when I have this, look at this. I already know what is the cos 12. Now, so let me bring that back. I know that the cos 12 degrees. It's something that we can write as the cos of 2 times the 6, because that will give us 12. This will make sense. You'll understand why I need us to write it like this. So first thing first, remember the identities. How are the identities going? So the identities, they work like this. Identities, they work like this. For double angle, this is the cos of 2 theta. We can write that as 1 minus 2 the sine squared theta. That's the only identity that I'm interested with, because if I change this guy here, this will be where there's theta. Okay, let's say this is my theta. Where there's theta on this formula, you need to put 6 degrees. I hope you understand. So this tells you that we can write the cos 12 degrees to be equals to 1 minus 2 the sine squared of what? The sine squared, remember this is like saying cos 2 theta, and our theta is 6. So this will be the sine of 6 degrees. You see now, you just have to solve for sine 6. Then you're good to go. So let's solve for sine 6. First thing first, I know that the cos 12 is P. Okay? We just proved that the cos 12 is P. And then now I still have 1 minus 2 sine squared 6. So let's bring the 1 this side. So this will give me P minus 1. It's minus 2 the sine squared 6 degrees. Then let's divide everything this side by negative. So this is negative, divide that by negative, divide that by negative. This gives us 1 minus P. It's equals to 2 the sine squared 6. Too much work, ne? Because we still have to divide by 2 again. By 2. So this is just like saying 1 minus P over 2 is equals to the sine 6. So I'm just going to put this like this, and then I can square both sides. Therefore, how many marks? I'll definitely check the mark allocation, because I think like this is too much. 6 degrees is equal to the square root cancels, and this will leave me with 1 minus P over 2. And that's it. Wow, that was nice, ne? That was very, very nice. So this is how you answer those questions from that question paper, and I'm looking forward. Let me first check the mark allocation before we can end this one. Oh, that was 4 marks. It makes sense, né? And that's how you answer the question using sketch. Okay, this is where we're going to stop for this one, and I'm looking forward, guys, to see you on question 4. Look at this question for 17 marks. If this is your first time watching my lessons, join the family, subscribe to the channel, and let's work on that question 4 together. And that's it from me. Sharp, sharp. Thank you for watching.